Welcome to Calculus. Today we will investigate how to sketch a slope field and also sketch in a specific particular solution on that slope field. We'll take a look at one example. My differential equation for our example is the y prime equals 3 minus x. And we're told that we're specifically looking for the particular function that passes through the point 4 comma 2, y at 4 equals 2. Well, let's start off by creating our slope field. I see from my differential equation y prime equals 3 minus x that the slope, or y prime, depends only on the x value. I don't have any y values that are included on this specific example. So as I go to create a table, I'll place 3 columns. Again, I'll put one for x, one for y, and then the third column is for y prime, or the slope of each family of functions that goes on that slope field. Now, since this particular differential equation only involves x, it's the y prime equals 3 minus x, the only thing that's going to determine the slope is my x value. So I've got a y value or a y column in my table, but really it's not going to make much of a difference. So as I fill in my x column, I just want to represent each of these x values from the far left, which is -6, through 0, all the way to the far right, +6. So I'm going to put those values here: -6, -5, -4, -3, -2, -1, 0, and then 1, 2, 3, 4, 5, and 6. Now, I'm going to jump directly over to my third column, which is the slope, or y prime. And again, the differential equation defines y prime as 3 minus the x value. So for my first slope here at -6, I'm going to plug in -6 for x. So it's 3 minus -6. Well, that's going to be 3 plus 6. The slope here should be 9. And I can see, like, I have a y column here. Really, it's 9 for all values of y. So as I try to start sketching in, I'm just going to start here on the x-axis with a slope of 9. And it is approximate. I'm trying to indicate that it's a very steep positive slope. But just to demonstrate that this is the case for all the y values, all these slopes vertically are identical. They all have the slope of +9. So then we go to our next x value, which is -5. I'll plug it into the same differential equation, 3 minus -5, and that's 3 plus 5, or 8. So as I pass to the right from -6 to -5, I'm going to have, again, a steep slope that's slightly less steep, but still positive slope and identical for every y value. Now, I should say that that's not always the case for every differential equation. Some differential equations they determine y prime based on both x and y. This one just happens to be all on x. So again, I'll place all values for y there. And we can continue. In fact, we start to see a pattern. It's very linear. For the x value of -4, that's going to be 3 minus -4. 3 plus 4 is 7. And in fact, I can generate these values quicker now that I see the pattern. The slopes are decreasing by 1. So from 6 to 5, 4, 3. 3 minus 0 definitely is 3, 2, 1. Slopes of 0 at x values of 3, -1, and -2. In fact, all the way to -3 if we include 6. So that kind of completes it. So we just need to fill in here. I know that my slope, so what I'm going to do is I'm going to zoom forward to where I know the slope values are 0. So that's at the x value of 3. And I'm just going to go in there because those I don't have to estimate. Those are all flat slopes, all 0 slope. So I'll go ahead and place that one. And then what we can do is work our way to the left and meet what we had done on the far left there at -5 and so forth. So I see then if I back one up at +2, the slope is 1. So it's positive slope, but not particularly steep. This is the value of 1. And so all I've got to do as I proceed to the left is make my slopes more and more steep. So now I got slope of 2 at the x value of 1. So all these slopes I'm at this point very much approximating. It's really just important for me to show that there's a relative change as we go from x value to x value. So now at 0, I got slope of 3. And that's a little steeper than what I had at +1, slope of 2. As I go to -1, slope gets even steeper, 4. And that trend is going to continue as we make our way over here to the left. Steeper and steeper. And again, just approximating those values. We're not really carefully plotting these. At -3, the slope value is 6. So now it's getting really steep. And then as we fill in that last value at -4, that's a slope of 7. All that's left for us to do to complete our slope field is to fill in those slopes for x values of 4, 5, and 6. So I see at that value of x, starting with 4, the slopes turn from 0 slope or positive slope to the far left there to negative slope. In fact, -1. So now at a +4, all of my slopes have a value of -1. And like we saw on the left, we'll have a continuing pattern on the right where slopes get steeper. The only difference is these slopes will be negative. So as I pass to x is 5, the slope is -2. And the last x value I've got on my graph here is +6, slope of -3. And that completes the sketch of the slope field. So that's my first task, part A. I just wanted to sketch the slope field. My task for part B is now to use the slope field to sketch the solution that passes through the given point. So I just keep in mind that the slope field represents the whole family of functions that would be related to this differential equation. When I go to sketch a particular solution, I'm limiting it down from the whole family to just one particular solution. So what I've got to do there is find this point. So I can see that the point is really given by these two values. The x value is 4, the y value is 2. So I'm going to find that point 4, 2. And knowing that that is my particular solution, my graph is going to go through that point at 4, 2, and it's going to follow the slopes of my field as it goes from x value to x value. So I just want to sketch it in here. And definitely as I go to the left, the slopes get steeper and steeper. Same pattern continues here on the right. So definitely what we're looking at for our particular solution is a parabola, some kind of quadratic function. And that completes my second task, which is just to sketch the particular solution given by the initial conditions there. My third task is just to describe the end behavior. So I just want to say what's happening to that red curve, both as x approaches infinity and as x approaches -infinity. So the first value is here on the right side. Definitely, I'm seeing here that as x travels to the right, the y value is going to approach -infinity. It's decreasing continually. So we'll write that here as x approaches +infinity, y approaches -infinity. I also want to consider what's happening as x approaches -infinity. So as I look on the far left side of the graph, Even there, though, we have the same trend for our y value. That left side is decreasing continually, especially as we let our x value trend towards the left. So as I finalize my end behavior statement, as x approaches negative infinity or heads out to the far left, y still approaches negative infinity. And that completes my third task for this slope field with its particular solution. Thanks for joining for this example of how to sketch a slope field in a particular solution. See you soon.